right, we're moving on to section 7.4, which is the Pythagorean theorem. So before we get started, just wanted to go over a couple things. So first, just a reminder of the Pythagorean theorem. So it says if you have a right triangle with sides A and B and C, that A squared plus B squared equals C squared. So we will be using this for the lesson today. And just the most important side when dealing with a right triangle is the hypotenuse side, which is always directly across from the right angle. And then the A and the B don't really matter. They're interchangeable. The other thing, just really quickly, is our chart for how we know the signs in the different quadrants. So again, all students take calculus. So using this for the different quadrants to know positive or negative, because we are going to be continuing with sine, cosine, and tangent. And then also just a reminder of what our sine, cosine, and tangent stand for. So like our acronym, SO, CA, and TOA. And sine is opposite over hypotenuse, which is the O and the H. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So these are the three aspects we'll be working with for the notes today, and you'll be using these on homework. So right triangle, A squared plus B squared equals C squared. All students take calculus for determining the sign of the different trig functions, and then sine, cosine, and tangent. So the Pythagorean identity says that sine squared of theta plus cosine squared of theta is equal to 1. We will just touch on this. You will do a lot more of this next year in pre-calculus. So the problems you're going to notice, they give us a trig function, sine, cosine, or tangent. They give you what the value equals, and they tell you what range the theta lies in. So first off, cosine, we know, is adjacent over hypotenuse. So this top number refers to the adjacent side of a triangle. This bottom number refers to the hypotenuse side. Theta is between pi over 2 and pi. This tells you what quadrant. So between pi over 2 and pi, so if we just go over here, just in case we forgot. So here's pi over 2, here's pi, 3 pi over 2. Between pi over 2 and pi is quadrant 2. So this tells you quadrant 2. And again, we'll need that for the signs. So what you're going to do is you're going to draw this triangle in quadrant 2. So when you draw these triangles, they are a little bit confusing in the beginning. So the first thing to keep in mind is make sure, and the angle does not need to be exact. So I'm just going to draw something like that. It's obviously not correct, but it's in quadrant 2. This has to be the right angle, and then theta has to be connected to the origin. Okay, so just a quick note, your theta must be at the origin. So if you ever get confused about where your angle is that you're starting with, just go back to the fact that theta has to be the angle closest to the origin. And since this is theta, we want the adjacent side of theta. So the adjacent side is next to, which is here, which is going to give us a -3. And the reason we're taking the negative here is because I know if I go left on the x-axis, these are negative numbers. So if you're wondering how I knew to put the negative on top or bottom, you're going to have to just refer to a graph in an x-y coordinate and use your judgment based on where you're plotting your point. So since I'm going left on the x-axis, this distance has to be negative. Hypotenuse is 5, so we know the hypotenuse is always across. So what we're first going to do is we need to figure out what this other side is. So we're going to do a squared plus b squared equals c squared. And again, the only side that matters where you actually put it is the hypotenuse side. So this -3 can be a, it can be b, it does not matter. Okay, so we're going to do a squared plus b squared equals c squared. So a, I'm going to have it be -3. So -3 squared plus, I don't know b squared. That's the side I'm going to try to find. And I do know c squared. Sorry about that. So I have -3 squared plus b squared equals 5 squared. So then you can work it out from there. So 9 plus b squared is equal to 25. Subtract 9 to both sides. You get b squared is equal to 16. Now here's the thing is b could be 4, but it could be -4. And again, you're just going to have to use your judgment based on how you're moving. So if I'm trying to go up on the y, I know that's +4 direction. If I was in quadrant 3, I'd be going -4 on the y, and then I would use the negative. So we are not using the -4, we're using the +4, because again, I'm going up direction on the y. So now I have my b. So now you can go ahead and find the other two pieces that we're looking for. We're looking for sine and we're looking for tangent, and it will tell you on each problem. So sine of theta, and so remember what sine is. Sine is opposite over hypotenuse. So again, it's in reference to this theta. So opposite is 4, hypotenuse is 5. And then tangent of theta, again, here's theta, is going to be opposite over adjacent, so -4/3. And then just stop and double check. So if this is all students, so I know sine should be positive and everybody else should be negative, which is exactly what happened. So if somehow this -3 gets lost, just go back and double check your signs. And then the last part, it asks, does the Pythagorean identity hold? So what you're going to do is you're going to plug these values in to the sine squared plus cosine squared. Well, we have cosine up here, and see if it gives you a value of 1. So let me show you what that looks like. So we're going to do sine squared plus cosine squared. Okay, so we're doing this part right here, and you won't do this on all of them, but just a few. So sine, we have the value of 4/5, so you're going to do 4/5 squared, plus cosine was given. Cosine is -3/5 squared. And we're trying to see if that equals 1, so this is 16 over 25, plus that'll be a 9 over 25. Does that equal 1? 16 plus 9 is 25, and 25 over 25. So then you would just say yes, that the identity holds. And that's basically what we're doing today. So that same process repeated with some different elements. Let's go and try number 2. So number 2, they're giving us cosine again. So again, I strongly recommend in the beginning writing out which sides they give you, so that way you don't have to think about it. You can just plug it in. So adjacent over hypotenuse, and then 3 pi over 2 and 2 pi. This is going to be quadrant 4. And again, the reason this is telling you is twofold. It's telling you where to draw your angle, and it's telling you based on the signs, the positive and negative of the sine and cosines and tangents. So now if I draw my angle, and again, it doesn't need to be perfect, but it has to be in the right quadrant, so I'm going to put it there. It always hits on the x. Theta has to be the angle that's connected to the origin, so this can't be theta because that's not the origin. And then this must be my right angle. And now you're plugging in. So I have the adjacent. So again, adjacent is next to, so this is going to be 5. And we're going positive direction on the x, so that makes sense that it's a positive 5. And then the hypotenuse is 13. And we basically need to figure out what this side is here. So again, we're doing sine squared plus cosine squared. Or sorry, we're not doing that. We're doing a squared plus b squared equals c squared. So the only side again that matters, this has to be your hypotenuse, the 13. So I'm going to do 5 squared plus b squared equals 13 squared. And again, this order doesn't matter, so feel free to switch it up. So you get 25 plus b squared equals 169. Subtract 25 to both sides, you get b squared equals 144. So you know this gives you a 12 and a -12. We're only going to use one, but we want to think about which side of the triangle we're finding and what movement that is on an XY plane. So I'm going down on the Y. So this distance is down, so I'm going to be using the -12 here, not the +12. Okay, and again, if you were going to try to give me this point, you'd go over positive on the X and down on the Y, which is why that 12 should be negative. Now that we have our last side, we're going to find our sine and tangent again, because that's what it's asking for. So we're going to do sine of theta. So sine of theta we know is opposite, so negative 12 over hypotenuse, 13. We don't reduce these and make them into, well, we reduce them, but we don't make them into decimals. Generally, you keep them into whole numbers. And then we have tangent of theta. So tangent we know is opposite over adjacent, so negative 12 over 5. No impropers, no mixed numbers, so improper is perfect. And then just double check, because we had all students take calculus, so only cosine should be positive, which it is. Sine and tangent should both have negative values. And this question does not ask us if the identity holds, so then we're done.